Okay guys, so for this problem, I want to take my function x to the r and bound the region between y is equal to 0, x is equal to 0, and x is equal to 1, and rotate that region around the line y is equal to -2. And for that solid, I want to find for which r my volume of that solid is going to be equal to pi. So for that, let's first sketch our region. So our region is going to look something like a deformed triangle, where like the top part is going to be a function, a graph of the function, which is similar to parabola. And if I want to rotate or now visualize my solid, I need to rotate or like reflect my deformed triangle along y is equal to -2. And for that, I'm just going to reflect my points and draw exactly the same deformed triangle up to a reflection along y is equal to -2. And then if I'm going to connect right now my points between those two deformed triangles, you can visualize how your solid is going to look like. Our next step is to find the volume, or to express the volume using the formula that we're familiar with. We remember that we need to figure out what is going to be the radius of our solid, where our point is going to go around a circle. And that radius is a part of the formula for the area of the circle, and the volume is going to consist just the infinite sum of those circles. And you can see that our radius is going to be the sum of two numbers, where 2 is a distance between y is equal to -2 and x-axis, and x to the r is a distance between x-axis and my function. So that's why radius is going to be equal to 2 plus x to the r squared. Okay, but are we going to get the original shapes that we're asking to find? And actually no. If you're going to take a look at that cylinder, then you can see that that part of my solid is going to be empty. So what do you need to do then? You can think about this if I'm going to consider the original solid, or in other words like solid 1, which is going to be the shape that looks something like this. And after this, what do we need to do? We need to subtract our cylinder, or in other words, we need to subtract solid 2. And if we're going to subtract those two solids, we're going to obtain the original solid that which volume we want to find. So for that, just remember that the volume of the second solid is going to be given by pi integral between 0 and 1 2 squared dx, where again like we chose 2 because 2 is the radius of my cylinder. Okay, so our final formula is going to be pi times the integral between 0 and 1 of 2 plus x to the r squared minus 2 squared dx. And since we want to find for which r that integral is going to be equal to pi, then I'm going to just set that integral to be equal to pi, and I need to solve that equation for r. So for that, first I'm going to cancel out pi on both sides, and I'm going to expand my 2 plus x to the r squared. And you can see that 4 and -4 are going to cancel. Then after that, I just need to find the integral on the left hand side by applying the power rule. And I'm going to obtain 4 times x to the r plus 1 over r plus 1 plus x to the power of 2r plus 1 over 2r plus 1. And if I'm going to plug in my boundary points, since x when it's equal to 0, I will get just 0. I will have 4 over r plus 1 over 2r plus 1 is equal to 1. And we need to solve the equation for r. So that's why if we're going to multiply both sides by r plus 1 times 2r plus 1, I'm going to obtain those like parentheses, but after like simple algebra simplification, you can see that I'm going to obtain the quadratic equation, which is equal to 2r squared minus 6r minus 4 is equal to 0. And our goal is just to solve this quadratic equation. But if you're going to plug in our coefficients into quadratic formula, then you're going to obtain that r is equal to 3 plus minus square root of 17 over 2. But since r cannot be negative, as r is a distance, or in other words a radius, then I'm going to choose just a positive sign. So in this case, the only solution is 3 plus square root of 17 over 2.